Hi, welcome back to another video. In this video, we'll talk about 16E, position and average velocity. So let's take a look at these words that you'll often see in this topic. The first word is distance, and we're comparing distance to position or displacement. So when talking about distance, it is a quantity, so it's a number, and it'll always be positive. So speaking of distance, we're talking about distance traveled, and that's regardless of the direction. So if you have a look at the picture I drew on the right, these two people, they are 100 meters apart. So if one person's shouting hi, the other person says, I can't hear you. That's because they are really far away from each other, so it's 100 meters apart. Here we're talking about distance. So we say that the distance between these two people is 100 meters. Position or displacement, on the other hand, we're talking about relative location. The definition is the final position of the moving object relative to the reference point. So let's say if this person started at point O, he walked to point A, and then came back to O, and then walked to point B. What's the total distance he covered? So from point O to point A, that's 10 meters, and back another 10 meters, and then go to point B, another 10 meters. So the total distance this person traveled will be 10 plus 10 plus 10, which is 30 meters. So that's the distance. What about the position or the displacement? Remember, position or displacement, we're talking about the final position. So he stopped here, okay? He finished his journey at point B, therefore the position or the displacement will be 10 meters to the left of O, or negative 10 meters. And we define moving to the right as being positive and moving to the left as being negative. And the reason why we define it this way is because, so it's the same as a number line. If we are starting at point 0, point O, then moving to the right, you have all the positive numbers there, and moving to the left, you have all the negative numbers there. So that's why his displacement or his position will be negative 10 meters. So we have just compared distance and displacement or position. Let's now compare speed and velocity. Speed is how fast something travels. We also know the formula that can calculate speed is distance over time. And speaking of speed, we don't care about the direction. So it doesn't matter which direction you travel in, the speed would just be the speed. So if you look at the picture on the right, this car is traveling at 100 kilometers per hour, then this would just be its speed. So velocity has direction, and the definition of velocity is the speed of something in a given direction. So we do care about direction when it comes to velocity. Again, if you look at the picture here, if this car is moving forward, then we say that the velocity of it is 100 kilometers per hour. It's positive. I should probably specify that it's positive. So if this car is moving forward, then the velocity is positive 100 kilometers per hour. If the car is moving backward, then we say that the velocity is negative 100 kilometers per hour, because for velocity, we do care about the direction. So here's a question. A particle is moving along the straight line. Let x meters denote the position relative to O at time t, where time is measured in seconds. We have 3 dot points giving us important information here. So at time t0, the position is 0. That makes sense because we haven't moved. That's our starting point. Maybe let's label this as point O. So that's here, that's our starting point. The second dot point says at time t is 5, x is 6.25 meters. So after 5 seconds, our position is 6.25 meters to the right of O. I will label this as point A. Okay, the third dot point says at time t is 8, x is negative 8.96. So this means after 8 seconds, the position is 8.96 meters to the left of O. Maybe let's label this as point B. Okay, so at t equals 0, the particle starts from rest and moves to the right. At t is 5, the particle stops and moves back to the opposite direction. This means this is our initial position. So this particle started at point O and it moved to the right. And when it gets to point A, it's going to head back. So from point A, it's going back to point O again. And moving past point O, it continues moving to the left until it hits this position, so 8.96 meters to the left of O. And we say that the position to the right of O is positive and to the left of O is negative. So we already talked about this before. So here are two things we want to keep in mind. The first thing is when the graph is on the right hand side of 0, then we say that it's positive. So in a time versus position graph, it's going to be the graph that's above x-axis. And when the position is to the left of O, we say that it's negative. And in a time versus position graph, it's going to be the graph that's below x-axis. Now let's have a look at this question. This is our starting point O. And as you can see, so I use the color yellow here. We're moving to the right until we reach point A, which is after 5 seconds, we're now 6.25 meters to the right of O. So this first coordinate here is labeled as point A. After 5 seconds, the position is 6.25 meters to the right of O. So this corresponding x value here on the vertical axis is 6.25 meters. And then the particle stops and moves back in the opposite direction. And if I now change to green, that's why the graph is going down. So we're moving back in the opposite direction, but it's still on the right hand side of O. That's why the graph is still above x-axis, okay? And at t equals 7.1, this is this point right there. So when t equals 7.1 is when we're moving past point O. And from this point onwards, our graph is below x-axis because now the particle is moving on the left-hand side of point 0. And you can say that after 8 seconds, the position is going to be negative 8.96. So maybe we can label this point there. So this final position will be point B, 8 and negative 8.96. So after 8 seconds, the particle finally stopped moving, and its final position or its displacement is 8.96 meters to the left of O. So note that from t equals 0 till t equals 7.1, the position is positive. So particle is to the right of O. This makes sense because from point O, we're moving to the right first. And once we hit point A, we're going back to point O again. Although we're heading back, we're moving back in the opposite direction, but our movement is still on the right-hand side of O. That's why the graph is above x-axis. And for t is greater than 7.1, the position is negative. So this means the particle is to the left of O. Remember that we said the particle moved past point O, but it didn't stop. It continued moving to the left until it reached point B. So it continued to travel in the opposite direction until it reached point B. So using the same example and same graph, let's now calculate the average velocity. And to calculate average velocity, we have this formula here. So it is equal to change in position over time elapsed. So think about this. Remember we said velocity is basically speed with a direction. And speed is equal to distance over time. Then velocity is going to be position over time. So average velocity is change in position over time elapsed. We can also say that average velocity is the average rate of change of position over time. So usually you would have your horizontal axis being x and vertical axis being y, but here we're measuring time versus position. So that's why we're using different letters here. So t for time and x for position. But that's okay, it doesn't really affect our calculation. So we want to find the average velocity over the time interval t is greater than or equal to 0 or less than or equal to 5. When time is equal to 0 and when time is equal to 5. Let's just label them as t1, t2. And this should remind you of the x1 and x2 values we used to take. So when t is equal to 0, what's the corresponding position? What's the corresponding x value? We know that at time is equal to 0, the position is 0. And when time is equal to 5, the position is 6.25. So we essentially have our two ordered pairs given to us in the question. They are 0, 0, and 5 and 6.25. So as you can see, we used to use x1, y1, x2, y2, but now it just becomes t1, x1, t2, x2. They are the same. So the first value corresponds to the horizontal values, and the second value corresponds to the vertical values, in this case time and position. So now let's calculate the average velocity between these 2 points. So difference in x values, x2 minus x1 over t2 minus t1. So this is going to be 6.25 minus 0 over 5 minus 0, which is 1.25 meters per second. So the average velocity is 1.25 meters per second. Okay, what about the average velocity over the time interval 5 to 8? Let's have a look. So I'll label this as the second part, so part B, and this was part A. So to find the average velocity over this time interval, we're essentially finding the gradient of this green secant line. And sorry, I forgot to mention, in part A, when finding the average velocity over the time interval between 0 and 5, we're finding the gradient of this blue secant line. The good thing is that we know the 2 points and their coordinates, so we can just use x2 minus x1 over t2 minus t1 again to calculate the gradient, or the average velocity in this case. So x2 will be negative 8.96, that's our final position. So negative 8.96 minus 6.25 over the time elapsed, so the time intervals 8 minus 5. This is equal to negative 5.07 meters per second. So maybe you're wondering, why is the average velocity negative here? The reason why it is negative is because we're moving in the opposite direction. So this point here, I think we labeled this as point A before. Point A is when we changed direction. This also happens to be the turning point. So in the first 5 seconds of this particle's journey, it's moving to the right. After the turning point, the particle changed its direction. It's now moving in the opposite direction. So that's why the average velocity is negative. Okay, so here's a question. Let s of t equals 6t minus t squared be the position function of a particle moving in a straight line where t is in seconds and s in meters. So s clearly is the position and t is the time. In question A, we want to find the average velocity for the time interval 0 to 1. So time interval means t1 is 0 and t2 is 1. So let's first plot the graph. We know it's going to be a quadratic function, and this parabola will be facing down because the coefficient in front of t squared term is negative. Okay, so we have a graph that looks like this, facing down. And if we accurately plot the graph, we can label some points. We know point 0, 0, that's our starting position. So in question A, we want to find the corresponding position when t is 0 and when t is 1. So let's sub in the values into this equation. When time is 0, the corresponding position is going to be 6 times 0 minus 0 squared, which is going to be 0. So at time 0, the position is going to be 0 as well. So that's our first ordered pair. At time t is equal to 1, the corresponding position is going to be 6 times 1 minus 1 squared, and this is going to be 5. So average velocity is equal to change in position over change in time. And in this case, it'll be s2 minus s1 over t2 minus t1. Our s2 is 5 and s1 is 0. T2 is 1 and T1 is 0. So it's going to be 5 over 1, which is simply 5 meters per second. So the average velocity over this time interval will be 5 meters per second. Now this makes sense because for this interval, our graph is above x-axis. So it's to the right of point O. Alright, question B says find the average velocity for time interval 6 and 8. Okay, so still let's sub in the values. When t is equal to 6, the corresponding position is going to be 6 times 6 minus 6 squared, and this is going to be 0. When time is 8, the corresponding position is going to be 6 times 8 minus 8 squared, which is going to be negative 16. Using these 2 points, we're going to find the average velocity for the time interval between 6 and 8. So average velocity is equal to x2 minus s1, change in position, over time elapsed, t2 minus t1. and it's going to be negative 16 minus 0 over 8 minus 6, and this turns out to be negative 8 meters per second. So as you can see, this green secant line denotes the motion during this time interval. And the reason why the average velocity in this case is negative is because our particle is moving in the opposite direction, which makes sense. And finally, before we end the video, I just want to quickly mention that since I've been talking about finding average velocity is the same as finding average rate of change, and we've been using secant lines, so as you can see, this blue line and this green line, they're all secant lines. But how do we connect these two concepts together? So average rate of change is equal to the difference in y value over the difference in x values. So essentially y2 minus y1 over x2 minus x1. And for average velocity, our y values becomes the position and our x values becomes the time. We also know that position over time is equal to speed or velocity. Okay, it should be velocity because it's speed with a direction. So hopefully this can help you to see the link between average rate of change and velocity more clearly, because we've been using secant lines to find average velocity. So if you're wondering why that's the case, then hopefully this line can help you to understand this a little better. And I hope this video is helpful and hope to see you in the next video. Bye!